Hey everyone, today we are going to talk about how you can factor a quadratic expression in the format of x squared plus bx plus c. Before we start off, there's some important concepts that you need to follow. So first of all, to review, factoring is when, just like with a normal number like 15 per se, you're going to break down that number into its factor or its smaller pieces. So with today's lesson, when we are factoring quadratic expressions like x squared plus bx plus c in that format, we're going to break them down into the two binomials that would multiply by each other to get to that expression. X plus 1 times x plus 2 will get us to x squared plus 3x plus 2. Just like how 15 can be broken down into its two factors of 3 and 5, so that 3 times 5 will get us back to 15. Okay? And you probably noticed that we were talking about quadratic expressions. This you should put into your notebook as an important vocabulary word: quadratic expression. Quadratic expressions are expressions that can be simplified to the form ax squared plus bx plus c, where a, b, and c are just placements for numbers. So this right here, x squared plus 3x plus 2, is an example of a quadratic expression. So as long as it has the x squared in there, that's what is differentiating it from other expressions. When you have the x squared, it is a quadratic expression. So some examples are x squared minus 6x plus 3, negative 7x squared plus 5x minus 2. So 7x plus 3 would not be a quadratic expression because it doesn't have the x squared as its highest power. And x cubed minus 2x plus 1 is also not a quadratic expression. Its highest power for x is cubed. And you probably remember that 7x plus 3 is actually a linear expression. It will make a straight line on the graph. Okay, so from now on, if you hear quadratic expression, all we're saying is that it's an algebraic expression where it follows the format ax squared plus bx plus c, and its highest value for the x variable is squared. So we use the example of 15, and if we need to factor 15, we need to figure out what 15 can be broken down into. It can be broken down into 3 and 5, because 3 times 5 will give us the product of 15. Similarly, with quadratic expressions like these in blue here, we can factor them into their factors so that when they are multiplied back together, like x plus 1 times x plus 2, when it's multiplied, the product is actually the original quadratic expression. Okay, so again, in this lesson, you are going in reverse and you need to figure out what those factors were. So in order to do that, I gave you 4 different quadratic expressions and worked out the factors for you. I would like you to pause the video and see if there are any shortcuts or patterns. Because if we can figure out any shortcuts or patterns, then it'll make our life really easy when we're working backwards. So go ahead and do that. Okay, so let's see, what are some patterns that we're noticing? Well, first, I noticed that all of these have x squared as the first term in their quadratic expression. Okay, and I noticed that the first term in each binomial is just a single x. That makes sense because later on, when I multiply using whatever method that I want to use, the x is going to be multiplied by the x. The first terms are going to be multiplied by each other. So that's how I get x times x, and then that x times x becomes x squared in each of these cases. Okay, so when I have a quadratic expression in this format, x squared plus ab, sorry, not ab, x squared plus bx plus c, right? So meaning no term, or sorry, coefficient for the first term that is other than 1, because if there's nothing there, it's a 1. In this format, I'm going to have my factors start off with just x, because in order to get to 1x squared, I have to have x multiplied by x. That's the first pattern that you might have noticed. Let's see another pattern. Well, another pattern you probably notice is that these last terms right here, 1 and 2, 3 and 2, this is a -2 and a -2, -5 and +2. You probably notice that they're always being multiplied together to get that last term, that c. So 1 times 2 is the 2, 3 times 2 is the 6, -2 times -2 is the +4, and the -5 times the +2 is the -10. Okay? So that kind of helps us out a little, because that's going to help us figure out this last term, but not quite yet, right? We do know that the product is going to be the c value. Okay, so let me write that on the side here. The c value is going to be the product, what happens when we multiply these last two terms. Okay, what else do we notice? Well, let's see, we still didn't talk about this huge chunk right here, these middle terms in our quadratic expression. And we know from previous lessons that these will be combined. So this is 1x plus 2x, which is 3x, 3x plus 2x, which is 5x, -2x and -2x, which is -4x, and -5x plus 2x, which is -3x. So we are adding those together. Let's see if that relates to these two terms, these two last terms over here in our two binomials. Let's see, I get 3x here, and let's see, 1 plus 2 is 3. 3 plus 2 is 5. So far, so good. -2 plus -2 is -4. Okay. -5 plus +2 is -3. Yeah. So we notice that the b, the coefficient in front of that second term, should be the sum of my two numbers that I put inside my binomial. That right there is our shortcut. So go ahead and put that into your notebook, and then we'll do 2 problems to practice. Okay, so before I move on to the next screen, I know that this only works when the coefficient for the first term in your quadratic expression is 1, so that I start off with x and x inside. And then the two numbers that I choose inside each of the binomials have to multiply to make that third term. And then they have to add, their sum has to give you the coefficient of the second term. Okay, so let's try some examples together. Here is example 1. We need to factorize, or factor, x squared plus x minus 12. You can go ahead and pause the video and try it on your own first if you think you got it. All right, so I'm looking to see if it follows the same format where I have a coefficient of 1 for my first term, x squared, plus, we'll call this bx plus c, okay? Because we need to remember that since there is a coefficient of 1 there, just a normal x squared, I can already go ahead and fill in these x's in the front because they're going to multiply together to get x squared. Okay, the other thing I remember from my shortcut is that the c, the last term, is going to be the product of whatever two numbers I choose. The b coefficient in the second term is going to have to be the sum of the two numbers I choose. Okay, so I'm looking for two numbers that multiply to get me negative 12, but add together to get me 1, because there's really a 1 here. Okay, so I need two numbers that multiply to get to negative 12, but they add each other to get to a positive 1. So let's see, I can start by listing all my my factors of 12. I have 1 and 12, 2 and 6, 3 and 4, and I think that's it. So any of these will obviously multiply together to get to 12, but I'm also looking for the pair that will add to get to 1. Now keep in mind there's a negative here, right, for your 12. So that means one of those numbers has to be negative, so that a negative times a positive will be a negative 12. Now, since 1 is going to be negative and 1 is going to be positive, when I'm adding them together, it's not just like a straight addition. I'm adding a negative number and a positive number, so I'm really like subtracting them. Okay, so I'm looking for a difference of 1. That would leave me with, and let me change my color, that would leave me with 3 and 4, it seems, right? Because 3 times 4, a positive and a negative, will give me negative 12. And then if I change this, let's see, it's a positive 1 when we add them together. I'll need to make this 3 negative and keep the 4 positive, so that this is negative 3 plus 4, or really 4 minus 3 to get me 1. And then I'll have to keep that negative 3. Negative 3 times 4 is negative 12. Let's try it out. So I have x minus 3 times x plus 4. That should be my answer. Let's check. Let's use FOIL to check, okay? Because I already have my first terms, x times x. X times x is x squared. Now I'm going to multiply my outer terms, x times 4, which is positive 4x. And then I have my inner terms, negative 3 times x, which is negative 3x. And then my last terms, negative 3 times positive 4 is negative 12. Do these add up together to get me back to positive 1x? 4 minus 3x? Yes. Becomes a positive 1x minus 12. So this checks out. So my final answer, I'll rewrite it over here, is x minus 3, the quantity of x minus 3 times the quantity of x plus 4. Okay, and I use my shortcut. I needed to find two numbers that would multiply to get to negative 12, my c value, my product. But those two numbers also had to add together to get me my b value, that coefficient of the middle term, of 1. And because it was a negative 12, I knew one of them had to be negative. So it really wasn't adding to 1, it was subtracting to 1 when we look at just the digits. So that answer is x minus 3 times x plus 4. Let's do one more example. If you didn't try the last one, see if you can pause the video and try this one on your own now. Factorize x squared minus x minus 20. So here, remember, we want to get to the product of negative 20, but also the sum of negative 1. Okay? So I'm going to draw my little boxes again. I need to multiply to get to negative 20. Don't forget those negatives. And then I need to add to get to negative 1. Okay? So again, I'm going to first start off by listing my products. That'll get me to 20 first, because that'll help me eliminate a lot of numbers and get me some pairs. 1 and 20, 2 and 10, 3 doesn't work, 4 and 5, and I think that's it. Okay, so then now I'm going to see, well, one of them has to be negative, right? Because I need to get to negative 20. So one's positive, one's negative. So again, I'm not really adding in the traditional format. I have a positive and a negative, so I'm really going to be subtracting my values. So I need then 4 and 5, because they're only one away from each other, okay? My sum at the end is negative, so that must mean my bigger number, the 5, is going to be negative. Okay, so it's going to be negative 5 and 4. That'll add up to negative 1, and negative 5 times 4 will multiply to get to negative 20. And remember, since there is a coefficient of 1 in front of the x squared, I just have a normal x in the front. And then I'm going to put in my numbers. So I have a minus 5, or negative 5, and I have a positive 4, so that becomes a plus 4. So this should be my answer, but let me just double check by using FOIL. First times first, that's x squared. Outer times outer, so x times 4, so that's plus 4x. Inner times inner, negative 5 times x, that's negative 5x. And then my last terms, negative 5 times 4 is negative 20. These get added together. 4 minus 5 is negative 1, so it's a negative x minus 20. Is that the same? Yes. So this right here is my factorization of x squared minus x minus 20. Okay, so you're just figuring out the two magic numbers that'll go into your binomial that have to meet both those conditions for product and sum.